Hello and welcome to E233. I'm your instructor, Gregory Myers. In this video, we're going to take a look at an older version of our P5. Your current P5 may be a little bit different from this one, but the principles will still be the same. This video is going to focus on the setup of our P5, including handling the command line arguments. This video assumes a number of things that you have been following along with the earlier projects, focusing in this case on our physics demo, but we'll have also started to look into the use of vectors or arrays. The big distinction with this particular video or with this particular project, as opposed to the previous projects, is that we'll be using vectors to calculate multiple values and then ultimately passing those vectors by reference to the functions so that we can then retrieve those values or use those values in the calling function, in this case, our main. And this video, once again, is going to focus mainly on the setup of our program, including handling the command line arguments, and we'll handle writing the functions in a later video. So this assumes that you have obtained a copy of the current P5 instructions. I've also provided for this particular video a sample file with some of the arguments that would be passed, in this case, the interactive behavior of our executable, and optionally, this setup file. Now, I'm going to encourage you to move away from the use of these setup files, as I will not be providing them all the time. And instead, what we want to do is we want to get comfortable essentially creating these functions ourselves based on the function prototypes. And then optionally, I would encourage you to refer back to your own P4 for some guidance on the functions themselves. So let's go ahead and get started. We'll go through the instructions and we'll take a look at the overview to see what the differences are. But fundamentally, we have the same problems: the one-dimensional motion, two-dimensional motion, and the simply supported beam. We ultimately want to interact with our program either using command line switches for scanf, or rather interactive mode that will require the user then be prompted with a printf statement and followed up with a scanf statement, or we're going to pass those arguments when we launch the executable, in which case they will be parsed from our argv. The big difference you'll notice is in these function prototypes that in addition to passing vectors, that we also must pass an n. And the idea is that the user will have some control over how many points we wish to calculate. So for instance, for the projectile 1D version 4, the idea is that we would drop a ball off of the top of the building and we would still go ahead and calculate the amount of time it took to hit the ground, but we would also be able to calculate a time vector, a y time vector, which essentially demonstrates the position as the ball is falling, and a vy time vector, which demonstrates the velocity as the ball falls. And the number of values in each one of these vectors will be controlled by our last argument, n. So basically, in addition to collecting the information that we collected in the earlier projects, we will now also have to collect an n, which will simply tell then our calling function, or rather be passed from our calling function to our little helper functions here to indicate how many calculations we wish to do. Now, in addition to this, you'll also notice that this project has some output, not only to the console, but to files. And so this would be a good time for you, if you've not done so, is to look at some of this videos in the file demo series, because unlike earlier videos where we would be doing batch piping to an output file, we will actually be handling the responsibility of printing the results to a file inside of our executable. And you can see here that in addition to presenting some information back to the user on the console, we also want to output a CSV file that, in the case of the 1D version 4, will have n rows where n corresponds to the number of calculations the user asked to be made, and 4 columns where the first column is simply the index associated with the vectors, so we can understand how they relate to the time, y, and then ultimately vy. So let's go ahead and get started now looking at the switches so you can understand how the behavior in this one changes. Now, I should have provided you with something similar to this for your project, or you will have created this. But the idea here is you'll look at how our argument count and the arguments themselves have changed with relationship to our earlier projects. And from this, you can then derive your if structure that will ultimately triage your command line arguments. You'll notice that the /1D/2D and /beam options are the same for the interactive mode. In other words, basically, none of the switch behavior changes, just the questions that are asked to the user changes. We'll take a look at that again in our sample file. But you will notice there is a change to the /P options. And we'll start with the /1D/P. And you'll note that where earlier there was one additional argument, our Y init, we now have two additional arguments, the Y init and N, where N is the number of arguments that, or excuse me, the number of calculations that we wish to provide in our function. Same with our /2D/P. You'll notice that where earlier there were two additional arguments, there are now three additional arguments, with that third additional argument being the number of data points to calculate. And in the case of our /beam/P, the number of arguments did actually not change. However, we did change that last argument from the A, or the location on the beam, to N, where N represents the number of points that we wish to calculate the load at. And so essentially what this is this is a precursor to a loading function. Although in this particular case, we're just going to keep the load itself constant. So let's go ahead and see how we would handle this in our executable. And so I've done a little bit of work here in that I've simply created a p5.c in our p5 project. I've went ahead and created a nice comment block up top. I have my standard includes, of which we will have to add a couple more. And I have my comment block in front of main, as well as my for loop that simply goes through each one of the arguments passed to the executable. From here, what we want to do is we want to start handling our logic, and we'll do something similar to what we did in the earlier projects, in that basically what we want to do is we want to look at the arguments and determine whether or not they were a valid combination of arguments, and if not, we want to call help. And at this point, probably the logical thing for us to do would to go ahead and stub in all of our functions, including our help. Now, once again, you can leverage this p5 setup.c, or you can simply leverage the instructions. So in this case, even though I've got my p5.c, I'm going to encourage that we go ahead and use the instructions directly. And so I'll go ahead and add the function prototypes as I have defined them, and go ahead and provide an additional function prototype for our help. And at this point, what we want to do is we want to convert these prototypes into their respective function stubs. And so you'll see here then that just involves swapping out the semicolon for a pair of curly braces. And in the case of the earlier functions here, where we have an int for a return value, we simply want to go ahead and set up that temporary variable and return either exit success or exit failure, or return that results value. In this case, our int is just going to simply demonstrate success or failure of our function. So we will simply use a results that we will initialize for right now to exit success rather optimistically, and then we will return our results. We'll try to do some preliminary error checking then in a later video. At this point, we simply want to go ahead and copy this code to each one of our functions, with the exception of our help. And then you want to go ahead and obtain a copy of the template that I provided earlier in the semester that gave you, I guess you could say, a little bit of guidance, if you would, for the comment block in front of each one of the functions. And I would simply like for you to include the name, the description of the function, as well as each one of the arguments. Now, I'm not going to go through each one of these in this video. I'm going to leave that for you to do, but you do want to go ahead and provide that for each one of your functions, as well as for your help. Now, the last thing that we want to go ahead and do with respect to our functions in this video is to go ahead and stub in our help. Now, I'm going to do this in a little bit of a reverse order. I'm actually going to build the help first based on the argument example that I gave earlier. So that way we're essentially done with the help, and then we can use that as guidance in creating our triage for our switches. And so you can actually go back to your old P4 if you wish to, and you could take a look at your help there to get some guidance on how to go about doing this. And for that matter, you could probably also go ahead and borrow a little bit of code. And in this particular case, that's exactly what I'm going to do, is I'm going to leverage my old P4 to create the help for our P5. And of course, then we simply want to do some creative find and replace. In this case, I'm going to replace everywhere where there's a P4 with a P5. And then also, I want to go ahead and handle the additional arguments. And once again, what I mean by that is I want to handle the scenario for /1d/p, where originally I only provided a y init, but now I also want to provide an n. Also, we want to update the example. And so what we want to do here is we will change this then to reflect that slide. We'll simply then provide the additional argument for the /1d/2d. And then remember, as I said earlier, the difference with the beam is that our A from our earlier projects then simply gets replaced with an N. So the total argument count actually does in fact not change. At this point, our help is fairly complete. We can always improve on it, especially the descriptions here. And we can probably go ahead and close some of these files, or at least get them out of our way. And what we can do now is we can leverage our own help to build our command line arguments. So we'll start off here with the scenario where basically our argument count is insufficient, meaning that the user did not provide at least 2 arguments. And where did I get that from? Well, if the user provides 2 arguments, they could possibly be the /?, the /h, or perhaps some nonsense. But at least we know we have at least 2 arguments to triage. And in all 3 of those cases, /?, /h, or some sort of nonsense, then we know that we want to call our help. And so the first thing that we want to do is we simply check that our argument count is in fact not greater than or equal to 2. And we do that by simply checking to see if it is less than or equal to 1, or what we can do is we can just simply say if argc is less than 2, we make an implicit call for help. Now, under the else branch here, we can start looking at some of the scenarios where they have in fact provided some additional arguments that could be useful to us. And what we'll do is we'll start looking using our string compare I at our argv^1. And if it in fact matches the /?, or string compare I, looking at argv^1 matches the /h. And we're going to go ahead and use an extra set of parentheses here. If either of those scenarios are encountered, then we are going to make an explicit call for help. This simply means that the user intended to bring up the help, by either providing a slash question mark or a slash H. I think you can see at this point how you can extend this to any sort of combination of slash question mark and slash H, maybe even including a dash question mark and a dash H. And then before we forget, we also want to provide the else scenario. And the else scenario, once again, is an implicit call for help. And basically what this does is this catches all of the scenarios that we did not explicitly define. In other words, the user did something that we didn't expect them to do. Now, continuing on with this pattern, what we can do now is we can look at the argument count as well as the arguments themselves to see whether or not we have a valid switch combination. And the first one that we want to do, which is very similar to our P4, is simply then going to be to check to see that our argument count is in fact equal to 3. But not just that. We also want to check to see if string compare I for the argv square brackets 2 or the third argument now matches slash I. And if in fact both of those conditions are met, what we want to do is we simply want to make a call to our interactive 1D. And we'll do that right now by simply providing a little bit of a print statement in here, a little bit of feedback back to the user that says calling slash 1D interactively. Now, at this point, we can either continue to handle the slash 1D options or go ahead and jump ahead to handle the slash 2 and the slash beam interactive options. And once again, I'm going to try to do this one a little bit differently in that I want us to look at a flat structure. And so what I'm going to do is I'm going to go ahead and make 2 copies of this. And the idea here is that I want to call the 1D interactively, the 2D interactively, and the beam interactively. Now, in order to accomplish this, I have to differentiate between these 3 scenarios. And this is where we're actually going to leverage a third condition in our if statement. So basically what we're going to do is we're going to look to see if our argument count is equal to 3 and our argv square brackets 1 is equal to either slash 1D, slash 2D, or slash beam. And so what we want to do is very carefully modify each of these scenarios to look now additionally at our argv square brackets 1. And if it matches slash 1D and it matches interactively, this is going to be how we differentiate calling 1D interactively from calling the 2D interactively versus calling the beam interactively. Now, you'll probably notice that I'm intentionally doing this triaging different than I have the earlier projects, just to give us a little bit of variety. The downside of this approach is this is going to have much of a more of a flat else if structure, which means that we're going to have many, many more options broken down linearly. Might result in a little longer code, but it just gives you, once again, a little bit of a different perspective on how to handle your switches. What I would encourage you to do is to try both approaches and see which one works the best for you. Now, what we want to do now is we want to stub in the additional combinations. In other words, our slash 1D slash P. But if you go back to our table, you'll notice that the argument count has to change. So in other words, now for this scenario, we're going to have 5 arguments where the argv square brackets 1 is 1D, argv square brackets 2 is slash P, there is some value for argv square brackets 3, and likewise for argv square brackets 4. So not only does the arguments themselves change, but the argument count does. So let's go ahead and stub this in here. And as I said from the table, our arg count changes. So now we are going to have arg c equal to 5. And string compare I for argv square brackets 1 must match our slash 1d. And string compare I is used once again now on our argv square brackets 2. And this time we're going to look to see if it matches our slash p. And if all 3 of those conditions are met, then at this point we simply say calling slash 1d parametrically. And once again, with a little bit of judicious copy and pasting, in other words, make sure to change the 1D to 2D. And once again, do the same thing for our beam. Then that leaves us only with changing the argument count and then putting a print statement in. So once again, we're going to go back to the 2D scenario for the slash p. You'll notice that I must have a total argument count of 6, and likewise for beam. And so what we can do now is for our slash 2D slash p, we simply change the argument count to 6, follow up with a print statement. This is calling slash 2D parametrically. And then lastly, for the slash beam slash p option, we also want to have 6 arguments. And we simply then put a print statement here that says calling slash beam parametrically. At this point, we've written a fair amount of code. We haven't wired them up yet to our functions, but we can at least check to see if our switches are triaged correctly. And so let's go ahead and build our P5. We have success. And so we can come out here to the command line. We'll go ahead and cd over to our P5 dist debug and min.gw folder. And there's our P5.exe. And just to go through some of our switch combinations, no switches should result in our help being displayed. Likewise, we can explicitly put in our P5.exe and do slash question mark, and sure enough, that gets us help. Slash H gets us help. And then some sort of nonsense here will also get us help. So far our help is working. Let's try our other switches. And specifically what we want to do is check to see what happens when we only put in 1D. Well, 1D does not provide enough arguments. We either have to provide it with slash I or slash P and the additional arguments. So once again, we get the help. That seems to be working correctly. Slash 1D slash I gets the print statement saying calling slash 1D interactively. Slash 1D slash P should also get the help because we've not provided additional arguments. Let's go ahead and do that now. So 111. And sure enough, we get now calling slash 1D parametrically. We can do the same thing for our 2D, first by itself, then with slash 2D slash I, that gets us slash 2D interactively. Slash 2D slash P gets us the help again because there are insufficient arguments. In this case, we need to provide it with the v init and our theta. as well as the number of data points that we want. And sure enough, we get calling /2D parametrically. And then for the final scenarios, then we have /beam, which once again by itself is not enough. /beam/I is enough to get a /beam interactively. /beam/P does not. And then we just simply need to provide then the additional pieces of information. And sure enough, we now get calling /beam parametrically. So at least it looks like our P5 is now correctly wired from the perspective of our command line switches. So hopefully you found this video useful. As always, if you have any questions, comments, or concerns, don't hesitate to contact me, and thank you for watching.